Here's a really simple algebra problem where we've got 3c and 4 and it's equal in value to 13. What I might want to find out is the value of c. And this is how we're going to do it. Let's look at the problem a different way. Instead of actually writing out 3c add 4 in your traditional number form, let's look at it as a bar, 3c's and 4. And that bar is equal in size to 13. But what I can see here is if I were to get rid of 4, then I would be left with 3 lots of c. But what am I going to take 4 from? Well, 13. So let's do that. 13 take away 4. Pretty sure you all got through a reception. The answer is 9. So 13 take away 4 is 9, which means these 3 lots of c have a value equal to 9. Well, that's not too bad either, is it? Because I know if I share 9 by 3, I'll get the value of c. And 9 divided by 3 is 3. So then, let's return to the original problem. We looked at 3c add 4, which is 13. We realised that 3c add 4 equaling 13 means I can actually remove 4 from 13. You might look at it as an inverse. 13 take away 4 equals 9. 3c has a value of 9. So we started with 13. We subtracted the 4 because we're doing an inverse, and we were left with 3c. So what we'll do here is 9 divided by 3, which equals 3. So c equals 3. So we looked at bar model, we looked at inverse. Let's try some more. Okay, this problem tells us 2a add 1 equals 10. First of all, I'll look at it as a bar model. I'd hope to see you using rulers, of course. So here's 10, and I know, let's say that's 1. So that's a, and that's a. 2a add 1 is 10. Okay, so first thing I'm going to do is let's try and get rid of this 1. Then I'll just be left with 2a. So 10 take away 1, which equals 9. Which means that these 2 lots of a must have a value of 9. Okay, so if 2 lots of a have a value of 9, I'm doing an inverse, so 9 divided by 2. Half of 9 is 4.5. So a equals 4.5. There's my answer. This problem looks a lot harder than it actually is. You have 6b, you're subtracting 2b. And your answer is 40. Well, actually, we have b and b. What's 6 take away 2? 4. So 6b take away 2b would leave us with 4 lots of b, which here would be 40. So I know if I was to return to my bars, here's 1 bar, there's 2 bars. This bar's a value of 40, and that's 4b. Now if that's 4 equal sections, all I have to do now is 40 divided by 4. Do not get this one wrong, which is 11, or are you kidding, 10. Which means that b has a value of 10 as well. If I want to prove it, I do the opposite. If b is 10, well, 6 lots of b will be 60, 2 lots of b will be 20. 60 take away 20 would equal 40. There we go. I've tried it, I've used bar models, and I've proved it as well. Here's another one that looks far harder than it actually is. So we've got 4a plus a equals 6. Okay, let's think. How many lots of a have we actually got? We've got 4 lots of a, and we've got another lot of a. So what we've actually got is 1, 2, 3, 4, 5 lots of a. and they are equal in value to 6. So we've got A, and they're all equal to 6. So that's 5 equal sections which have a value of 6. So 5 times something equals 6. So that's 5 times A equals 6. So the inverse would be 6 divided by 5 equals A. I can do that. 6 divided by 5, well 5 goes into 6 once with a remainder. 1 remainder 1. If I know that I've watched my video on finding remainders as fractions, that's 1 and 1/5. And if I'm a real clever clog to know my decimals, that's 1.2. So A is equal in value to 1.2. Easy peasy.